So thanks everyone for joining the session. So today is day one of CCNP, and I was welcomed all CCNA candidates for two classes. Okay, so BGP is very vast technology and it's very important. Okay, fine. And so routing protocols. So routing protocols are divided into two types based on autonomous system number. First of all, what is autonomous system number? As we discussed before, it's a routing domain platform. So in routing domain, so you will configure routing protocols on router, right? So anyhow, I was running a company service provider, so I'm configuring a routing protocol. Okay, so that router, the physical router, is belongs to which company? So you will give a host name. Generally by you using host name you will understand, but electronic devices at the back end, how they will understand I'm belonging to which company or which domain. So you need to configure autonomous system number. This autonomous system number will tell you, you know, this router is belongs to this company. So each and every autonomous system number, each and every company will, you know, having autonomous system numbers. Okay. So suppose if you see, right, Google autonomous system number, you can see here, every company will have autonomous system numbers. See, it's a Google is the biggest thing. They have a bunch of routers. They have even Airtel, whatever service providers. Okay, Airtel. So which I have already discussed in CCNA classes, but I'm showing you now here as well. So Airtel. So it is also having autonomous system number. So Geo, whatever you see, right? Every company will have a autonomous system number. Even if I want to establish a company and I'm using bunch of routers, those are advertising in public, yes, I need to use the autonomous system number. Okay, so yeah, so now it's a 2 byte number. It means 2 to the power of 16. Okay, so total autonomous system numbers will start from 0 to 65,535. Here the public, here the public autonomous system number range is 1 to 64,511. It means you need to purchase it from IANA organization. Okay, you need to purchase from IANA, and the private is this. You can use internally. Okay, 64,512 to 65,535 are private ASS, and 1 to 64,511 is what? All are public ASS. So if you see, right, this is a old map. In this world, in every country there are a lot of service providers. In US we have, okay, in US we have Comcast, AT&T, and there are a lot of service, right? So those are connected to each other. In India, Airtel, Jio, Tata Communications, Sifi Technologies, there are a lot of service providers. Each and every service providers are connecting each other like this. All companies through this world. So how they're connecting? Through under ocean cable. Okay. So every service provider is connecting each other in this world. So the example, right? You know, you know, where whatever happens, whatever happening in US, we are able to watch on live, right? How we are able to watch on live? Because all are connecting each other here. Okay. So now, if you want to implement a routing protocol within the autonomous system number, we use IGP. We learned also OSPF and EHRP. We implemented as well. In CCNP, we implemented ISIS. I'll teach ISIS here as well. Okay. Now, between the autonomous system number, if you want to configure a routing protocol, which routing protocol we use? BGP. So in OSPF real-time project which I described, right, there we use BGP, right? So between the autonomous system number, which routing protocol we use? BGP. Okay. So the real-time example of BGP is, so once you type, if you're able to call, what is that? So from your phone, you're using a Airtel SIM. If you try to call Geo number, the call will go, right? Yes or no? How it is going? So you are using Airtel SIM and you are able to call Jio or BSNL or whatever it is. Because in India, all the service providers are connecting each other with BGP. They're establishing a communication with EBGP. So Airtel is one autonomous system number, Jio is one autonomous system number. Between them, we used to configure EBGP, external BGP. Guys, understand what I'm saying? How the communication is happening from one network to another network, Airtel network to Jio network. Between them, we used to configure a routing protocol called BGP. Make sense, everyone? Understand? Hello, what I'm saying,
Yes,
Yes,
bro.
sir.
right? Yeah. So in IGP, the neighbors are discovered automatically. In interior gateway protocols, right? OSPF. Once you start advertising the interface network in OSPF, the neighbors are discovered automatically. But in BGP, it is not like that. Okay, you need to specify the neighbor. Hey, you are my neighbor. Okay, you need to specify the neighbor. Okay, so and one more thing, BGP is a path vector routing protocol and BGP uses TCP. When you know, if you see CCNA class, right, TCP class, when I discuss about TCP, right, transport layer protocol called TCP, right? So I told you TCP is ruling the world, right? TCP, because of the TCP, the internet is, you know, established. Yes, the BGP is a service, internet service, and also called a routing protocol. It uses a TCP, and TCP port number of BGP is 179. Very important. So what is the port number of BGP? It is 179.
179.
Why it is using BGP? Because you know about TCP, it's a very reliable protocol. Until you deliver the data, until it deliver the data, right, it will keep on transmit it. And yeah, so that's the advantage of TCP. Okay, so whatever the services are using TCP, right, first what will established, can anyone please tell me, whoever is using TCP, how TCP works first?
Three-way
Establishes
handshake.
the connection.
Yes, very good. First it will establish a connection. So that connection is called three-way handshake process. Okay, three-way handshake process. Okay, fine, I'll explain it today. So BGP is a exterior gateway protocol. It's a path vector protocol. Why we call path vector protocol, I'll explain it. And BGP uses TCP and the port number is 179. And in BGP, you need to configure neighbors manually. You need to specify it. Okay, and also BGP has a lot of advantages. Okay, going forward you will come to know. So you can implement the BGP routing protocol within the autonomous system number also. Okay, so generally the BGP is designed to, you know, configure between autonomous system number because of the great advantages of BGP. Okay, so they are using within the autonomous system number also. If you use BGP within the autonomous system number, we call IBGP, internal BGP. If you use BGP between the autonomous system number, we call external BGP. Understand everyone? Hello?
Yes, sir.
Yes,
Yes.
bro.
Okay.
Yes, sir.
If you use BGP within the autonomous system number, we call internal BGP. If you use between the autonomous system number, it's called external BGP. Okay. Yeah. So let's focus on now. I don't want to, right, how I will teach. So I don't want to go with the PPTs. Let's learn with the real stuff. Okay. Yeah. Let me stop this. Hmm. Okay. So same like OSPF. How many OSPF packets we have, guys? Please tell me.
Five.
What
Five.
are those?
Hello packet, DVD packet, LSR, LSU, LSA.
LSA and LSA, na?
LS,
LSU.
LSR, LSU.
Okay, LSR, LSU, and LSA. Very good. So, as I said, right, in OSPF we have a five kits. OSPF have five kits. You know, right? Each and every packet, what it will do during OSPF adjacency process. I have explained it, right? Everything. So, which packet will do what, right? Yes or no? During OSPF adjacency process. How many states we have in OSPF?
Seven states.
Seven states. Very good. So, similarly, same way in BGP, we have four messages. Guys, please remember, I am requesting you, everyone, when you are talking about particular protocol, the keywords are very important. Like ARP, right? When we learn ARP, in ARP header, what are the fields which we are having? Sender IP, sender MAC, target IP, target MAC, right? But in normal L2 header, we used to call source. So, but in ARP header, we are calling sender. So the meaning is same, but the keywords are different, right? Similarly, in BGP, I'm telling you the important keywords. Whenever you are talking about BGP, you must use those keywords so that the people may understand you are a professional network engineer. Okay, what are those keywords? Routes. So routes you call prefix X here. Okay, you no need to use routes. You used to call prefixes. Prefix means prefix is also a routes. Okay, in BGP and packets, right? OSPF packets, right? Generally, here we call what? Messages. Okay, packets we call messages, routes we call prefixes, and uh, if you want to send a routes, right, we used to call advertisements. Very important. BGP advertisements. Without advertising any network, nobody can receive anything, right? So these advertisements will carry by update message. So if you see in OSPF, right, we have a link state update. In that link state update, you will see all the updates, right? It will, you will see it will carry a, if any network changes, right, in OSPF, immediately the update, link state update will generate and send it to all the OSPF routers, right? So link state update message will carry the routes. Similarly, there is a update message, it will carry the routes. Please keep this in your mind. These are still a lot of for there. When time comes, I will explain it. But keep this in your mind, okay? So now, what is this? Okay. Now, how many BGP messages we have? Total four. First one, BGP open message. Okay. BGP open message. And second one, does anyone knows? Second one is
Keep alive.
very nice. Keep alive. And third one is update,
Update
and
and notification.
notification. Yes, notification. So OSPF have five childrens and BGP have four childrens. Okay, understand? And you know, right? In OSPF five packets, why they are important during adjacency process, they will help you, right? Here also in BGP during adjacency process, this will help you. Okay, these are four messages, and we have several states as well. We have several states. I'll explain it here. Okay, so if you see, right, BGP open message, keep alive message, update message, and notification message. Very important. So it's not like OSPF. We have a hello packet, lot of fields we need to learn. OSPF header we need to learn a lot, right? So here you don't need to remember much fields. Very important fields I'll tell you. Okay. In OSPF, sorry, in BGP header, you have a version. This is open message. So it's like a hello packet. Okay, it's a open message. Please remember open message. It has a version. What version it is? BGP version. Do we have any BGP versions? No, we have
Oh,
only one BGP version. You know, right, why they don't have BGP, another BGP version? If they have another BGP version, BGPs will not establish because BGP versions should match at the both the sense. Both the sides version should be matched. That's why they did not develop any version. In case if they developed any other version, versions will be mismatched and entire countries are isolated. Entire internet will be collapsed. So that's why they're not touching version. So these parameters, right? They are developing these parameters and advancing the BGP. That's it. Okay. So anyhow, version is there and autonomous system number, right? Your autonomous system number and the timers, whole timer. Okay. Whole timers are 180 seconds here, 3 minutes. Okay. Whole timer is 180 seconds. Hold timer means in case yeah, a router 1, router 2 is there. BGP is established. Somehow link went down. So immediately BGP will not go down. It will wait for 180 seconds. After 180 seconds, it will announce, hey, the link went down. We don't have reachability. So, and I'm announcing BGP is down. So it will wait for 180 seconds and then it will down. And now BGP identifier, it's a router ID, right? Router ID, router ID. Okay. And these are the optional parameter length and optional parameters. Optional parameters are very important. Okay. So only these fields you have to remember. Guys, I told you, right? How how mu- how you practiced OSPF packets after practicing OSPF header, hello packet header, DBD header. Things are very easy to understand, right? Yes or no? What do you say?
Yes, bro.
Yes, sir.
Similarly, in your BTech and intermediate, you may practice so many diagrams, so many tables. Those will not help here, but these things will change entire your networking profile. So please practice these headers. Make sure you will be top on in your networking domain. So BGP, open message, these are the fields: version, autonomous system, hold timer, BGP identifier, and optional parameters. And in here, you will see authentication type and data as well. Okay. So each and every field I have described here, go through the PPT, okay, and learn it. Okay. And we have TCP header, right? BGP uses TCP. So everyone knows source port, destination ports are important fields, and you may learn SYN flag and acknowledgement flag. Okay. So today, if it is possible, I will complete other flags also, or else some other day. Okay. And BGP update message. Okay. BGP update message is very important. It will carry the route, BGP routes. In internet, you may have millions of routes, right? Yeah. So BGP will carry a routes, path attributes. What do you mean by path attribute routes? I'll tell you. Okay. So here, withdrawn routes means in case if BGP is down, right, the routes will be withdraw from your routing table, right? Because the session is down. You have to remove routes from your routing table. Okay. So if any link goes down, it will carry a withdraw routes. If any link is established, session is established, it will carry a routes as well. So update message generally what it will carry a BGP routes. Okay, BGP routes prefixes. Okay, na? So yeah, and BGP notification. So notification means it is telling. Notification means you will get a notification, right? If any text came in your WhatsApp, right, you will get a notification. Similarly, once BGP is established, right, if it is went down, it will tell you why it is went down. Why? Due to hold time expire or authentication mismatch, we have a lot of error codes. Why notification message generated? What is the code? Okay. Yeah. So please prepare well about these packets, especially update message and open message. These two are very important. Please prepare well. Okay. Now let's understand BGP. Okay, so far so good. Anyone having any questions? Hello, go on mute if you don't have any questions. Anyone having any questions? I was just explaining BGP messages. What are the important fields in that? Okay, so if you learn very well at OSPF, right, it is easy. Okay, so yeah, now let's understand. Okay, if I configure a BGP, okay, on two routers, what will happen? Let's see that. Okay, take two routers. Okay, there are two routers here connecting each other. So everyone knows EBGP configuration, right? Yes or no? Everyone knows EBGP configuration. We did it right in during OSPF
Yes.
real-time
Yes, sir.
project. Yeah. So anyhow, I'll teach you here one more time. Okay. So this is what? This is two routers. They are connecting like this. Okay. 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 Now, okay, let's see like this. Okay. This is 1.1, this is 1.2. Okay. R1 and R2. So now, if you see here, right? If you configure BGP, okay, if you configure BGP, so what is the configuration here? So both are same autonomous or different autonomous, doesn't matter. It's okay. Let's understand it is AS100 here. Okay, this is AS200. Okay, whatever it is. Okay, now what is the configuration of BGP? R1, simple.
Router BGP.
Yeah. So first you need to just like same like OSPF, same here. Router, routing protocol, right?
BGP
Router
100.
BGP and
100.
100. And now you need to tell your neighbor manually. What is the R1 neighbor IP?
1.2.
1.2.
That's it. You need to tell, hey, you're my neighbor. Manually, you need to do that. Okay. 1.2. And this 1.2 is belongs to which AS?
Remote is
200.
200.
200.
That's it. Simple commands. That's it, right? Anything is missing here? That's it, right? This is a configuration you must do on the device. Okay. So now once you initiated this configuration, right? What will happen, BGP uses TCP, right? First, it will establish a TCP three-way handshake process. Okay, it is establish a it is establish a TCP connection by doing three-way handshake process. First, BGP will be in idle state. Remember, the first state is what? Idle state. Okay, the first state is what? Idle state. Okay, this is idle state. In idle state, the BGP is down. Okay, because you did not configure any BGP. Once you configure BGP here on R1, the TCP port number 179 enable, because BGP is a service. You configure a BGP on R1, immediately TCP port number 179 is enabled here. Okay, and also it starts sending a what? It starts sending a synchronization. It should establish a TCP connection, right? So once you configure BGP, it's enable a TCP port number 179 to listen a traffic from R2. Also, it is sending a TCP SYN packet, SYN segment, you can say. So now let's talk about IP header from here. So what are the two important fields in IP header?
Source IP.
Source
Source
IP,
IP,
destination
destination
IP.
IP.
Very good. So what is the source IP here?
1.1.
1.1.
Okay. So before that, let's configure here also. Configuration is very important. So here router BGP 200, right?
Yes, sir.
And 1.1,
Mutation.
100. Okay, right. Now, source IP address is what? 1.1.
1.1.
And what is the destination IP?
1.2.
1.2.
Whatever the neighbor IP you given here, right? Neighbor IP, that is the destination IP here. Now, next layer is TCP. So in TCP, it uses source port as random, you know, right? And what is the destination port here?
179.
179.
Very good, because BGP uses TCP port number 179. Very good. Everyone understanding this? Hello, each and everyone,
Yes, sir.
Yes, sir.
right?
Yes, bro.
And now in TCP header, we have a important field flag in bit will set to 1, right? Yes or no? Okay.
Yes.
This R1 packet, and once you configure BGP on router 1, okay. So R1 will send this SYN segment to R2, and immediately it will move to which state? Connect state. Okay. Immediately it will move to connect state. Okay. You have to tell exactly this way. Okay. To the interviewer or to anyone. This is how at the back end is exactly what is going on. Okay. R2 receives this packet. And now, what is your BGP configuration here? You configured neighbor as 1.1. Yes or no? On R2, you configured your BGP neighbor as 1.1. It means your R2 router expecting a TCP packet from 1.1. Yes or no? R2 router expecting a BGP packet, TCP packet from 1.1. So, as R2 expected, it receives the TCP packet from 1.1. Yes or no? As R2 expected.
Yes, sir.
The
Yes.
as per the configuration, it is matched right here. Yes or no? First of all, once it receives, it will check the destination port number 179. Yes, I have configured BGP 179 is enabled. I listen the traffic. Then it will check the destination IP address is this. Yeah, 1.2 is mine. Here, BGP will also check source IP, because my neighbor is 1.1. I'm expecting a TCP packet from 1.1. Yes, I received each and every field it receives. Each and every field it will check it. Once it is check it, right, R2 is responding now. So tell me, what is the source IP? R2 is responding now. What is the source IP?
1.2. 1.2.
What is the
One dot
destination
two.
IP?
One dot one.
1.1.
179.
So here source port is 179. Destination port will be random one, whatever it is generated. And see here it will generate SYN as well as ACK.
Act equal to 1.
So this ACK is for previous SYN, and it is also sending a SYN packet. Okay. So it is going here. It means, so same way here also will happen na. So here also we have idle. Immediately once it is sent a packet, it is also in connect state. Now if you see, right, R2 is responding here. So in connect state, it is waiting for SYNAC. Please remember, in connect state, it is waiting for what? SYNAC. Okay. SYN plus ACK. Once it is received SYNAC, it means okay. Whatever I send a SYN segment, R2 is acknowledged here. Okay, fine. So immediately what it will do? R1 immediately will send a acknowledgement packet. Immediately it will send a acknowledgement to R2 immediately, and then quickly move to which state? Open send. Open send state. Okay. So in idle, it will send a SYN segment to R2. R2, you know, matches with all parameters and responding with SYNAC. Immediately R1 what it will do? It will send a acknowledgement for this SYN, right? Whatever it receives. And it will give you acknowledgement to R2, and then it will move to open send state. Okay. So this is SYN only, right? Okay. SYN, and this is what 1.1. This is the first packet. 2. Okay. 179. So you see, right? SYNAC ACK. This process is called three-way handshake process. As you see here, right? Same way. See, first it is sending SYN packet to router. This responds with SYNAC, and then immediately it will send the acknowledgement packet. This is called three-way handshake process. Okay. So once you have completed three-way handshake process here, immediately it will move to open send state. Okay. So upon completion of three-way handshake process, the TCP connection is established. Immediately it will move to open send state. In case if R2 is not responding, it means some parameters not match, maybe configuration, maybe TCP port number, maybe 179 may be blocked. Whatever the reason, R1 is not receiving SYNAC. Okay. Whatever the reasons, R1 is not receiving SYNAC. Okay. If it is not receiving SYNAC, it will keep stuck in connect state for how many minutes? 180 seconds, 3 minutes. So this is a connection timeout value. Okay. It will wait for 180 seconds. Still it is not receiving any SYNAC. It will reset it. It will reset its connect time. It means it will start from zero again. It will immediately reset its connect timer and move to which state? Active state. Which state? Active state. In active state, it is try to again establish a new TCP connection with the router 2. Again, it will try to establish a new TCP connection. Okay, makes sense? Again, it is try to establish a new TCP connection with device, peer device. Okay, guys, understand what I'm saying?
Yes,
Yes,
sir.
bro.
Yes.
Yeah. Hello, can you hear me? Yeah.
Yes,
Yes,
bro.
sir.
Yes, yes.
Yeah. So now in active state, right? Again, if it receives SYNAC, it is send a SYN, right? Again, it will receive SYNAC, it will go to open set. Otherwise, if it is not SYNAC, again it will set a connect retrieve timer to zero again, move to connect state. So it is jumping from connect state to active state. Keep on, it will jumping until it establishes a TCP three-way handshake process. It will keep on jumping it from connect state to active, active to connect. Make sense now, everyone? Understand?
Yes, sir.
Okay.
Yes.
Yes.
So now successfully completed TCP three-way handshake process, whatever the state it is. Now you are at open send state. Now in open send state, the router one will start sending BGP open message. So just now we discussed, right? What are the parameters you will see in BGP open message?
Version,
Open kill.
Version, very
autonomous,
good. AS number,
autonomous system,
very good.
hold time, hold time,
Awesome, guys. You are rocking. Hold timer.
BGP identifier.
BGP identifier,
Wow.
optional
Parameter
parameter,
map. Attributes.
Optional parameters. So optional parameters you will may see, you will understand soon, like MPBGP and route refresh things. Grace, there are a lot of capabilities we have that we can discuss later. Okay. Yeah. So these are the things. Okay. So guys, you know, right? Whatever the concept, I used to teach at in-depth level, like CCI level. Okay. So, I- okay. Uh, yeah. Just a second. Okay, I got a message. Okay, so now, so the thing is, in open message, these are the parameters, right? This will go to R2. So R2 should match with all version. Anyhow, we have only one version. And autonomous system number, even if it is different, doesn't matter. No need to match. Hold timer, timers also no need to match. They will negotiate. Whatever the higher values, right? They will negotiate. But BGP identifier means router IDs. This should be unique. It should not be matched. This should be unique. Okay. Once If all parameters are matched, right, R2 will respond with what? R2 will respond with keep alive message. Okay, okay, you are my neighbor. So it will respond with keep alive message. And once it receives keep alive message, right, it will move to open confirm state. Okay, generally valid open message. So if it receives valid open message, here also it's same thing. Here also we have a active and then open sent, same open sent. Okay, so here also if you receive a BGP message from R2, right, here it receives it, it will match with everything. If you receive a valid BGP open message, it means valid BGP open message means all parameters are matched and BGP identifier is unique. Immediately what it will do, R1 will send a keep alive message to R2 and move to open confirm state. So both the routers will do the same thing and move to open confirm state. So in open confirm state, both the routers will exchange a keep alive messages. And then immediately what will happen once both are receiving a valid keep alives, immediately it will move to which state? Established state. Okay. This is BGP adjacency process. BGP states and how they came up. So if the BGP state is stuck in idle connect active, what kind of issue it is? It is a three-way handshake process issue. It means your neighbor IP. If you don't have reachability, will you establish a three-way handshake process? During DNS class, I show you practically right with Wireshark analysis. Okay, when you try to reach your website, first DNS will resolve, then after it will establish TCP connection with the website. Website server is located in some data centers. How it will establish a three-way handshake process? First, it should have a reachability. Reachability means you should ping the neighbor IP. Whatever the destination IP you want to establish a connection, that IP should be reachable now. That IP should be reachable. Okay. Then only you know what? You can it will start initiate TCP. Okay. Reachability should be there. So guys, in BGP, remember in BGP, neighbor IP we call whatever the neighbor statement you are giving, right? The neighbor IP we call what? Next hop. Please keep this in your mind. Very, very, very important. Whatever the neighbor IP you give here, right? That is called next hop. Or else you will give peer IP. You can call as a peer IP as well. Okay. Please important. It is very important. Please remember that. So otherwise you will be confused. So everything is same. But remember next hop BGP next hop is different. In BGP, the next hop means neighbor IP. Guys, are you understanding what I'm saying? In BGP, the neighbor IP is called what? Next hop. అర్థమవుతుందా? Hello? People.
Yes, sir.
Yes, sir.
So next hop means in BGP, it's a
Peer
neighbor
IP.
IP. Peer IP or neighbor IP. Okay, please keep that in your mind. Okay. Now here, keep alive, right? Yeah. Okay. So whatever we discussed theoretically now, shall we do lab basic EBGP and can we learn it? What do you think? This is
Yes,
called
sir.
IBGP or EBGP?
IBGP.
EBGP.
Come on,
EBGP.
Both are
EBGP,
different
right?
AS numbers.
Different AS numbers, right? Yeah. Now let's start packet capturing first and do configuration quickly. Okay. So people who are directly join in CCNP classes, guys, are you able to understand what I'm saying? Hello?
Yes, sir.
Yeah. If you have any questions, you can stop me and ask me. Okay. So now interface, what is the port number here? Oh, okay. Mm, yeah. So now interface G1/0 192.168.1.1. So I'm just assigning IP address and give no shutdown. Now router BGP 100. So once I start giving neighbor 192.168.1.2, so and remote AS is 200. Okay, it will start sending BGP TCP connection. First of all, is it sending now? It is not sending, right? Why? Because reachability is not there. ARP should be learned first. Okay, so I need to configure other side also. Until you configure, until reachability, until there is no reachability, there is no TCP SYN packet. Are you seeing any SYN packet in packet capture? Tell me, ARP is not learning. It is still asking. Okay, see, right? Yeah. Guys, is it make sense of what I'm saying? The concepts,
Yes,
interface,
Yes,
sir.
sir.
Yes, sir.
IP address 192.168.1.2. Now ARP may learn. No shutdown. Okay. Now router BGP what? 200.
200.
Neighbor 192.168.1.1 and remote AS what?
100.
100.
That's it. Now see the transactions. You will see plenty of transactions now. See. Hey, something happened here. What is that? So let's understand one by one, like how we did it in OSPF. Okay. So see here. Okay. Uh, okay. So as I said, right, initially R1 will send a TCP SYN packet first. Yes or no? Okay. See now. R1 is sending a TCP SYN packet. This is R1 1.1. See, as we did packet capture, right? One by one I'll open and show you. So in IP header, what is the source IP here?
1.1.
1.1.
What is the destination IP here? 1.2. So is it matched everything whatever we discussed? Hello?
Yes, sir. Yes, sir.
Yes, bro.
And please remember that in EBGP the TTL value is 1. What do you mean by TTL value? It's a time to leave. It avoids the loops in routing. So what do you mean by TTL value? So I'll tell you here. Go on mute, please. I'll tell you here. Okay. Uh, please go on mute. Please requesting you go on mute. Okay. So how loops occurs in routing domain? So this is the routers. Okay. These are the routers. Just understand. Okay. And they are connecting like this. Guys, you're understanding what I'm drawing here? Hello. I'm just consider these are the
Yes.
routers. Just consider these are the routes. Okay. So any packet. So if any packet, routing packet. So when it arrives here, right? It will go here and it will go here and it will go here. So this is called loop, right? So whatever you're sending to this router, again it is sending to this router, again this router is sending to this router, again it is coming back to you. That is called loop, right? So if anything loop happen here, it is keep on traveling across your routers and your router, whatever the packet receives, right? Routers. So router again it will check the IP header and process further, right? It means there is a burden on router CPU. So your router CPU will go high and it will impact on your services. So to avoid that loops in IP packet, right? In IP packet, there is a TTL value called. In IP, there is a TTL value. What is that? Time to live. It means how long you can survive. So if the time to live value is 10 here, just understand. If the time to live value is 10 here, okay. Now the packet will travel to the next hop here, and once it is sent to next hop, one router it is crossed, right? It will reduce TTL value by 1. and now the TTL value will be 9. And now this router again send this packet to here. Similarly, the TTL value will be reduced -1 because one router it is trust, right? So the TTL value will be 8. Okay, like this it will travel it until it becomes 0. Okay, once it is became 0, so once the TTL value is 0, the packet will get dropped. The packet will get dropped. So the TTL value maximum up to 255. Okay, it means up to 255 times it will be rotated. At the end, when it becomes 0, the packet will be dropped so that the loops will be avoided. Guys, understand what is the important of TTL value now here.
Yes, sir.
It avoids the loops like this. However, in EBGP, why TTL value 1? Because in EBGP, you must advertise, you must establish BGP peers with point to point only, because these point to point are public IPs, not private IPs. Here I am taking an example as a private IPs, but in real world, the EBGPs are established with public IPs, not private IPs. Okay, so it could be point to point only. You must establish BGP with point to point. That's why TTL value is 1. You can establish the BGP, EBGP with indirect also. However, you need to increase the TTL value. Multi-hop to command. I'll teach you later that. But understand in EBGP, the TTL value is 1 here. And now, guys, I'm moving to the next header. TCP. So in TCP, it said SYN packet is 1, equal to 1. Understand? Hello? Whatever I discussed theoretically, I'm showing it here practically. Guys, are you understanding what I'm saying? Hello?
Yes, sir.
Ardhamoutunda?
Yes,
Yes, sir.
Okay.
sir.
So this is a SYN packet. Okay, na? So this is it. So now R2, if the all parameters are matched right here, R2 will respond with what? See, source port is random, destination port is 179, right? Yes or no? Source port is random, destination port is 179, right? And now R2 is responding with what? You're sending a SYN packet, you're getting a SYNAC here. See, 1.2 is R2, it responding to R1, and what it is sending now? See, source port is 179, destination port is here. It is responding with what?
Synac.
Flag
Synac.
SYNAC, right? SYNAC. Okay. Now after that, R1 will send immediately acknowledgement. See, now three-way handshake process completed, immediately it will move to open message. See, after three-way handshake process, immediately you're seeing BGP open message in packet capture. Are you seeing it?
Yes, sir.
This is called open send state. So now you will see the BGP message. So in BGP message, this is the border gateway protocol. See, in BGP message, what are the fields we discussed? Version, AS number, hold timer 180, right? That's what I said, right? And BGP identifier, router ID. And these are the optional parameters, capabilities, you can say. I did not configure any capabilities, just, it's okay. Optional parameters. So these are the important parameters. If the important parameters are matched right here, okay. So R1 is sending a BGP message to R2, and R2 also sending a BGP message to R1. Both are exchanging BGP messages in open send message. And if the parameters are matched, R2 is sending keep a message to R1. At the same time, R1 is sending keep a message to R2. It means they will exchange a BGP open message, both routers, and then they will exchange a keep a messages. Okay, keep a messages. Then after it will establish a neighbors. See, this is open message, right? Both they will exchange. Then after parameters are matched, it will move to open confirm. They will exchange a keep alives. See here, this is called open confirm state. Keep alives here and here. Guys, are you getting me what I'm showing here?
Yes, sir.
It's a keep alive
Yes.
message. Okay. So after that, BGP is fully established. Once BGP is fully established, right? They will exchange the routes. Whatever the routes you're advertising it. Whatever the routes you're advertising it by using network command. Currently, I'm not advertising any routes here. If you see, am I advertising any routes here? Okay, I'm not advertising. So anyhow, whatever the routes you advertise, right? After that, after establishing a BGP, the routers will exchange your routes with update message. If you see, right, finally update message came into the picture. In update message, you will see these routes. Currently, I'm not advertising any routes. That's why you're not seeing anything here. Okay. Yeah. But finally, last one is update message. Okay. Yeah. In update message, they will carry the routes. This is a BGP adjacency process, like how they will establish. Okay. The final one is once BGP is established, then they will exchange the routes through update messages. Okay, guys. Understand? Hello. This is all about
Yes.
BGP states, BGP, messages and process. This is called EBGP. Is it interesting or getting boring?
Interesting.
Interesting.
ఫోర్స్గా చెప్తున్నారా లేదా నిజంగా చెప్తున్నారా? Everyone able to understand what I'm saying? Hello?
Yes, sir.
Yes, sir.
Very nice. Okay.
Yes,
అన్న
yes.
ఒక క్వైరీ ఉంది.
Yeah, please go ahead, brother.
అంటే ఇప్పుడు ఈబీజీపీ పాయింట్ టు పాయింట్ కనెక్షనే కదా, బట్ టీటీఎల్ వాళ్ళు 1 నుంచి ఎప్పుడు యూస్ చేస్తాం 2 అనేది?
అదే చెప్పబోతున్నా ఇప్పుడు నెక్స్ట్. Okay. So if you're, can I go ahead now? IBGP, indirect BGP. Shall we learn?
Yes,
Now,
sir.
one more question.
Yes, please.
Just going ahead for TTL, can we advertise any one network just to know the packet? What will be
I'm
the
going to
inside
do
that? How
that.
it will update?
I'm going to
Okay.
do that. I'm going to do that. Okay.
Yeah.
Yeah.
Thank you.
Okay. Yeah. Going forward, we may advertise a lot of things. So just imagine in OSPF, I give a lot of projects. In BGP, it's ocean, right? You have to do a lot of projects. Yes.
Correct.
But basics we have to understand, right? I just going step by step. You know, right, about me, step by step. Okay. Yeah.
Yes.
So let's talk about something interesting. Okay. Let's let's do some crazy stuff here. This is R3 and this is R4. Okay. 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 And it is connected to here 2/0 1/0. Okay. This is what this is S200. Now, okay, what I can do here is let's talk about this. Let's configure. Hmm, I want to take spare. So let's talk about this. This is the AS200 only. This is completely AS200. This is AS200 only. Here it is BGP, right? Okay, no problem. Here also we can configure BGP, and the router is 2.2.2 is here. Okay, 3.3.3 is here. Okay, 4.4.4 is here. What is it? It's a loopback IP interface. Okay, it's a loopback IP interface. Everyone knows, right? Yeah. Now, so this is what? This is AS200. What is this? This is AS200. This is AS100. Okay. So R2, R3, R4 are belongs to AS200. This is AS100. Forget about between R1 and R2. Whatever we did it right, we learned it, we verified it. Now focus on this pink palla. Okay. Now let's configure it. Start and start. Now this is what this is AS200. Okay. See here carefully. So in AS200, so you can configure internal BGP. So within the within the AS, if you configure BGP, that is called what? IBGP, right?
Yes, sir.
IBGP. If you configure a BGP within the AS, that is called IBGP. Now I want to configure a BGP between R4 and R2. Indirect. Okay. So indirect, not direct, right? R4 and R2. Or else let me configure a BGP session between R2 and R3. R2 and R3 with what? With loopback IPs. Loopback is indirect, right? Yes or no? Now loopback is, what is the importance of loopback? You will come to know in BGP. So I want to configure the IBGP session between R2 and R3, and you know right here 192.168.23.2, and here it will take it 23.3. Why I'm taking this? Everyone knows, right? It is R2 and R3. So I'm just taking to remember easily 23.0 network. Okay. Since here it is a 2, 23.2. Since here it is a 3, 23.3. Okay. Now here 192.168.34.3.
34.3.
34.4. Okay. Now guys, only focus on between R2 and R3 now. I want to establish a session between BGP session between R2 and R3. If you want to establish a session between R2 and R3, indirect. Okay. So as I said, right? So let's do this. Let's configure first. Okay. As per the topology, let's configure it. Okay, quickly. I want to do quick configuration. Okay. So config T. So interface loopback 0, IP address 192.168. Sorry, not 192.
Loopback will be 222.
Yeah, it's 222, and the wildcard subnet mask is this. Now interface G 2/0 23.2. Okay, no shutdown. Now let's configure BGP here. So router BGP 200 and neighbor 3.3.3. My neighbor is 3.3.3 and
Remote is 200.
remote is 200. Now if you see, right, if your local AS is 200 and your remote AS 200, both are same, it is considered it is a IBGP session. Okay na? Your local AS is 200 and your remote AS is 200. It means the router will consider it's a IBGP session. Make sense? Hello everyone,
Ah,
Yes,
yes,
sir.
Yes,
sir.
sir.
right?
Yes.
Yeah, yeah. Now this is it. Configuration is done. I can write. Okay. Now on R3, guys, you must carefully watch what I'm doing right now. So very important logic I'm going to give you here. Okay. So interface loopback 0. If you miss single point, it's very difficult to understand. Please focus. Okay. Interface G2/0. IP address 192.168.23.3. Router BGP 200. Neighbor 2.2.2.2. Remote is what?
200.
200.
200.
Done. Now if you see, right, I have configured BGP, right? Let's see BGP will establish. Is BGP is establishing? See now.
No, I didn't
No.
see.
No.
So if you want to establish a BGP, first what you need to do? So go on R2 now. So what is my BGP neighbor here on R2? 3.3.3. So show IP BGP summary is, it's not establishing it. Okay, never, it's never tried. So 3.3.3 is not established. So troubleshooting process. So if the 3.3.3 is not establishing, first of all, TCP3, if it is in which state? Idle state. If it is in idle state, what is the problem? Three-way handshake process, right? So first of all, whether it is sending a SYN packet or not. So let's do packet capture. Is it sending a SYN packet? Nothing it is sending.
None.
Nothing it is sending. May I know why?
TTL
Neighbor.
value.
Not TTL.
SIP
Forget about
source.
TTL. So
We did not configure to our neighbor.
one second.
mismatch.
Let me conclude TTL. In EBGP, the TTL value will be 1, but in IBGP, not 1. Okay, I'll show you. It's an internal, right? So you can establish loopback with loopbacks. So first of all, the see, if you want to send a TCP SYN packet, what should you need do? What should you need?
It should have reachability.
Perfect. You should have a reachability. Do we have a reachability? Check it. Show IP route.
No, it got only reachability for interface.
It doesn't have reachability to 3.3. Do we have 3.3.3 route in our routing table?
No, sir.
No.
No.
So you don't have reachability, then TCP will not initiate it, right? So to get a reachability, what you need to do? You need to configure one IGP protocol. What are the IGP protocols we have?
OSP.
OSPF.
OSPF, ISI.
Yes,
OSPF, ISI.
yes. So you should have a reachability whether you can configure a static route or you can configure a OSPF. Let's configure OSPF. Now you understand, right? If you want to configure a indirect BGP peers, indirect BGP session, you should have a reachability. To achieve the reachability, what you are configuring one of the IGP protocol called OSPF. Understand? Now you may understand why companies are using OSPF or ISIS. Make sense, people? Hello?
Yes.
Yes, sir.
So
Yes.
for reachability, for neighbors reachability, shall we configure OSPF quickly on
Yes,
here?
sir.
So router OSPF something called 10 network 192.168.23.0 wildcard mask area. Let's consider say area 0
Area 0.
and network 2.2.2.2 area 0. That's it. Make sense what I'm doing? Hello, everybody.
Yes, sir. Yes, sir.
Yes, bro.
Router OSPF 10 network 192.168.23.0 area 0 and network, what is that?
3.3.3.
Okay, area 0. Fantastic, right? Now done. So now let's see you have a reachability. Do ping 2.2.2 now. Oh, you don't have reachability. So maybe
Not
point to
really.
point, maybe point to point not happening. What did I configure? Let's see show IP interface brief.
Redistribute ఏమన్నా చేయాలా సార్?
ఏంమా
రీడిస్ట్రిబ్యూట్ చేయాలా?
రీడిస్ట్రిబ్యూట్ ఎందుకు చేస్తావమ్మా? అవసరం లేదు. రీడిస్ట్రిబ్యూట్ ఏంటి? ఒక రౌటింగ్ ప్రోటోకాల్ నుంచి ఇంకో రౌటింగ్ ప్రోటోకాల్కి చేయాలంటే రీడిస్ట్రిబ్యూట్ చేయాలి. ఇక్కడ రీడిస్ట్రిబ్యూషన్ ఎందుకు చేస్తావు? జస్ట్ రీచబిలిటీ కోసం యు ఆర్ కాన్ఫిగరింగ్ OSPF. That's it. See, ping is happening now. First to check the reachability. That's it.
No.
You're not advertising one routes to another routes, one routing protocol routes to another routing protocol routes. You need just reachability. Ping avalante. So now both are pinging. It means they'll start sending TCP packet now. Let's see. See, they start sending, right? So OSPF is established. Once OSPF established, now BGP also SYN SYNAC ACK is done. See, right? SYN SYNAC ACK. Okay, 1 second. SYN SYNAC ACK is not happening. May know why? May know why?
Source IP, destination IP not matching.
Yeah. So guys, still it is not establishing. See, 23.2 is sending a SYN packet. Okay, 23.2 is sending a SYN packet. See here carefully. So reachability is there. It starts sending a SYN packet. Who? Our R2 23.3 is sending a SYN packet. See, which is source IP is this and destination IP is this. So here it is IBGP, right? For reachability we use OSPF. So it will take a TTL value of 255 in IBGP. Whatever the OSPF TTL value, it will take the same thing. Okay. So now if you see, right, source IP address is 23.2, destination IP address is 3.3.3. Are you getting my point? Hello. Hello.
Yes, sir.
Yes.
So our R2 router is everyone very important now. Our R2 router starts sending a SYN packet to R3 because we have a reachability to 3. So when it's sending packet to R3, always source what it will take? It will take a exit interface. What is exit interface? 23.2. What is the destination address here? 3.3.3.
3.3.
Now it is sending with SYN packet 1 here. SYN equal to 1. Okay. Now see carefully. This packet is arrived on R3. Now R3 is expecting a SYN packet from 23.2 or 2.2.2.
2.2.2.
Loop back.
Loop back.
Loop back
Setting for loop back.
because on R3 what we have configured?
2.2.
2.2.2.
My neighbor is 2.2.2, right? What I have configured on R3?
Loop backs.
See, do show run section BGP. What is my neighbor here on R3?
2.2.2.
I am expecting a TCP packet from 2.2.2, not from 23.2. So will accept by R3 router?
No, it will
No.
reset.
No.
Yes, it is resetting now. See now, it is resetting. Hey, I don't accept your packet. I'm resetting your connection. Now you will understand reset flag. There is a one more control bit, right? What is that? One more control bit, reset. See, it is sending, it is disconnecting it. Hey, I'm not accepting your TCP SYN packet because you're not my authorized neighbor. I'm expecting a SYN packet from 2.2.2, not 23.2. So I'm resetting your connection. Reset flag will set to 1, and it is acknowledgement means SYN packet. For SYN packet, it is acknowledging it. At the same time, it is resetting that. I'm not accepting your connection. I'm resetting that. Okay, because the router configuration is clearly saying that I'm expecting a packet from 2.2.2, not 23.2. Now, to make it work, what you need to do? Simple.
So
You
now
need,
it will stuck in active state.
yes, see here, do show BGP summary. It will still stuck in idle state because you never get a SYNAC, right, to enter into the active. So,
Okay.
so if you see right here clearly, in idle state, it is setting a SYN packet. If you're getting a SYNAC, right, it will move to connect. It is not moving to connect either. Okay, connection is reset, right? You got a reset flag. Reset flag means the connection is disconnected. Okay, so what you need to do now? Tell me.
బీజీపీలో నెట్వర్క్ అడ్వర్టైజ్ చేయాలి.
నెట్వర్క్ అడ్వర్టైజ్ కాదు. నెట్వర్క్ అడ్వర్టైజ్ చేయాలంటే ఫస్ట్
Update
నైబర్స్.
the source.
వెరీ గుడ్. సో you need to change the source address, right?
Yeah.
Yes or no? From
Yep.
R2, you need to change the source address as you need to replace 23.2 to 2.2.2.
2.2.
So there is a one more command in BGP, IBGP. Router BGP 200 neighbor. Who is the neighbor? 3.3.3.
Yeah.
And when you connect this neighbor, you need to go on mute, brother. Some background noise is coming. So update source loopback 0. So you have to update source as loopback 0, or else you can give anything. Okay, update source I'm giving loopback 0 because loopback, with loopback interface we need to advertise, right? Whatever the IP address on loopback 0, it will take it. Okay, you need in IBGP configuration, you need to specify this command, one more extra command. Why
So
it is
R3 loopback is 3.3.3.
where?
So how come it will be the neighbor?
What is that?
2.2 have.
Whatever it is, man. Where I am right now, where I am right now.
R3.
So what I am advertising? Okay, this is 2.2.2. You're
Yes.
talking about this? Okay, yeah, this
Yes,
is
sir. Yes, sir.
2.2.2. Neighbor is 2.2.2 and update source loopback 0. If I want to connect this 2.2.2 neighbor, I need to connect with my loopback, not with physical interface. So when you're sending a SYN packet, it will change with loopback. Okay, see now I did this here. On here you need to do this. neighbor 3.3.3 update source, sorry, update source, router BGP, this is router BGP, router BGP 200, neighbor, okay. Now if you see the packet capture, right, you may see three-way handshake process happened at the bottom. See, now 3.3.3, I just first I have implemented on R3 router, right? See, now 3.3.3 source IP is what? Now it's updated. Source IP address is 3.3.3, destination is 2.2.2 now. Okay, it's updated now. Earlier, source IP address is 192.168.23.3 earlier. If you see the previous packet, right? See here.
Yes, sir.
See, it was 23.3. Now I given a update source loopback 0. It means source address it is updating as loopback 0. What is the loopback 0 IP address here on R3? 3.3.3. Now it is accepting it. See, sin Synac hack is happened. Sin Synac hack is happened. And then BGP open messages and keep alive and done. Guys, understand the transactions here?
Yes, sir.
Yes,
Okay,
bro.
very important. Okay, so extra one more command will come in IBGP saying that you know what is that? Update source loopback 0. And as I said right now on R3, you just establish a BGP neighborship. That's it. Show IP BGP summary. The BGP is established, but you don't see any routes. If you see any, do you advertise any BGP routes? No. You just establish a neighbor. That's it. You have to advertise the routes. To advertise the routes, let's see. Go on R2 and advertise the routes. So what route you want to advertise? 2.2.2. Let's advertise 2.2.2. And mask. What is the mask? 255.255.255.255. This is a way to advertise a network. I am advertising this 2.2.2 on BGP to this neighbor. So now you can see here. So now on R3, I will receive this 2.2.2. See, I am receiving this 2.2.2 because of OSPF. So for BGP, we have a separate table, separate routing table. That is called BGP routing table. Show IP BGP is the command. So now are you receiving 2.2.2 network? Yes or no? Are you receiving it or not?
Yes, sir.
Yes.
Yes.
So 2.2.2 you are receiving now. And who is the next hop? What do you mean by next hop here?
Peer IP.
Peer IP. So for R3, peer IP is 2.2.2. Okay. Suppose let me advertise some other network. Tell me one more network, some 10.10.10.10 and mask 255.255.255.255. I am advertising this network on R2. See now. Now you are receiving this 10.10.10. It will take some time. Show IP route. Let's assign this 10.10.10. Origin is there, right? So interface loopback 1. So IP address 10.10.10.10. I'm taking bad mask. Okay, sorry. Okay. I just assign this 10.10.10 into another loopback and advertising in BGP. Now you will see here. See, now you will see 10.10.10. So what is the BGP administrative distance? 200. That is for what? That is for what? IBGP.
IBG.
It's a
BGP.
it's a IBGP, right? R2 and R3 are IBGP only, right? R2 and R3. It's a IBGP session. So what is a IBGP session? IBGP route administrative distance? It's 200. Okay, it's 200. How exactly it is receiving? Which peer? From 2.2.2. See, I'm on R3 router. I am receiving 10.10.10 route from BGP peer 2.2.2. If you check show IP BGP table, see, I'm receiving 10.10.10 from next hop. Next hop means peer IP. Okay, I'm receiving from peer. This route I am receiving. Prefix you can say. Okay, na? So what is the administered distance for IBGP? It is
200.
200.
200.
Now R1 to R2 it is EBGP, right? So this 2.2.2 I advertised in EBGP, right? So if you go on R1, do show IP route, you will receive
20.
2.2.2 via EBGP 20. Understand? Everyone understand? And R2
Yes, bro.
and R2 I advertised 2.2.2 network. So for it is going to EBGP peer. Who is the EBGP peer here? 1.1. So R1 is receiving 2.2.2 via EBGP session. It is a EBGP session, right? Yes or no? It is a VBGP session or not?
Yes, sir.
Hello? It's a EBGP session or not?
EBGP.
Right?
Yes,
Yeah,
sir.
it's EBGP.
So,
Different years.
so different AS, right? What is the administrative distance for EBGP? It is
20.
20.
20.
For IBGP, it is 200.
200.
200.
So this 2.2 is receiving from which peer? Who is R1 peer IP? Next stop.
1.1.
R1 neighbor
R2.
IP.
R2.
Please show BGP summary. 1.2.
1 dot.
It is receiving from 1.2. Make sense? Hello?
Yes,
Yes,
sir.
sir.
But OSPF is not configured in EBGP.
Why we used to configure OSPF? Why we need OSPF in EBGP? Tell me.
Only in IBGP is to discover the neighborship. We need to configure OSPF.
To discover the neighborship? To configure the no OSPF? No. For what purpose we
To reach
configure?
To reach
Areas.
for reachability.
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 Just route reachability. That's it.
Yes.
For route reachability, because BGP uses TCP, and how TCP will works, if you have a reachability to the destination, then it will start sending a SYN packet to establish a connection. If there is no reachability, TCP cannot work. So to just for reachability, we use OSPF. That's it. Okay. For which reachability, you can say precisely next hop reachability or peer IP reachability. Whatever the neighbor IP, right? For this neighbor IP reachability, we configure OSPF. Only for reachability, we use OSPF here. Make sense, everyone? This
Yeah.
is all about IBGP and EBGP with
Sir,
complete package. Okay. Yeah. I hope
sir,
everyone understand clearly. Yeah. Please go ahead. What is
sir.
that?
Uh, Actually, like, why we using IBGP? Because OSP, even when we install like a OSPF in the routing table, it will take only the OSPF because it has more trust value, right? All
Yeah.
the like
And
OSPF.
AD value. Okay.
Yeah, no, I mean, yeah, AD value is like 110, so it will only install the OSPF routes than compared to the IBGP routes, right?
Yeah. Okay.
So, and also like in OSPF for the neighbors connectivity as well, we had to do it manually. Where in OSPF it does automatically, and in OSPF is internally it doesn't
That's
matter for
okay. That
because
that that's okay. Your explanation is okay. What is your question? The question
like
is
I
why
mean
we
like
use OSPF, why we need IBGP, we have OSPF.
IBGP,
Okay.
yes, in
Let me
internally,
rephrase. Let me rephrase your question. We
yeah,
have OSPF, it is working excellent. Then why we need
yeah,
IBGP if it is already working in excellent way? That is what your question,
yeah, yeah, yes, sir, yeah,
right? So simple.
yes, sir,
BGP means internet. In internet, you will see millions of routes, millions of routes. So
yeah,
OSPF, if how OSPF works, OSPF will carry those routes in LSAs. If you see the advantage in the disadvantage in OSPF is it is having a link state database. Whatever the routers in that area, all the routers in that area have the same database. It means same kind of, what is that? Uh,
synchronization, like,
no, same kind of database you need to maintain. Okay,
oh
there is a
yeah,
limitation. Okay, so for BGP, it can carry lakhs of routes, and you can do lot of things with BGP. Hell lot of features are there with BGP. You can do path manipulation, internet routes. So suppose in service provider especially, suppose you can take in Airtel in India, they have thousands of routers, thousands of routers, they have to do lot of stuff. In BGP, we have lot of features. Okay, going forward, you will come to know why we use IBGP, why we use BGP within the AS, because we can provide the services to the customers like MPLS, L2 VPN, L3 VPN, everything with BGP only. Okay, so BGP is, for route processing, BGP is having more advantages than IGP. Okay, so going forward, you will come to know what is the advantages of BGP. For simply to precisely saying, answer for your question, OSPF have
Yeah.
limitations. BGP have advanced features. Okay, that's why we are using simple words. Okay, that features and all advanced things you will come to know soon. Okay, make sense? Understand?
Okay. Yeah.
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 Okay. Yeah.
Sounds good.
So this is what we have done on where here. Okay, so can I remove this? Is it okay to keep it here? Okay, let me paste the configuration here. Okay, okay, so this is R2 and I'm going to paste it R3 configuration as well. Show run section BGP. Okay, and then I'm going to paste you the routing table routes as well. Okay, so if you see on R3, show IP route. Okay, so this is a routing table. Please keep that in your mind. Okay, here is routing table. So just see the EBGP administrative distance. Okay, and IBGP table also. So guys, please remember, for BGP we have separate routing table called IBGP table. This is a BGP table. How exact it is learning, where exactly which peer it is learning, every information is there. Okay, so keep that in your mind and always check all these commands. Show IP BGP is a command. Okay, which network is learning from which next hop, very important. Please learn it. Please do this. Okay, do not miss it. Please do this. Okay, so here also I have it. Show BGP summary, you know, right, very well. So I'll keep this here on R1. Okay, yeah, so can I share this screenshot to you? So screenshots are helping you, right?
Yes, sir.
Okay,
Yes, bro.
so now I'm going to give a task. Establish a BGP neighbor from R3 to R4 as well as R2 to R4. I'm giving a task to you. Okay, establish a BGP peering between R3 and R4. Also advertise the networks 3.3.3, 4.4.4 in BGP. So you know, right, in BGP you no need to advertise network, same network on multiple times. Only advertise the network on single side. Wherever it is in BGP, it is IBGP or EBGP. Once you advertise in network, the BGP will carry the route. Okay, and guys, please remember, you have to advertise the networks here. Okay, so without advertising, it cannot propagate. So the task for you is configuring a IBGP session between R3 and R4 and R2 to R4 as well. Okay, let's see who will implement this. Okay, okay, that's a fantastic session. So is it useful, everyone? Learn something new today, experienced
Yes,
candidates?
yes.
Yes.
So in
Yes, bro.
interview they will ask you this level, packet level. I show you the packet capture, right? For every class I'm showing the packet capture. So what are the states and what is the packets, BGP packets internally, how they will exchange, and why we need update source loopback 0 in BGP. Why we need? If you don't give, BGP session will not establish because it is taking a exit interface IP as a source that is causing the issues. Okay, yes or no, that is causing the issues or not, right?
Yes.
Yeah, I showed you in packet capture. Yeah, okay, cool, then that's all for today. Thank you so much.